Topic 4, Matrices and System of Linear Equations. 4.1 Matrices, 4.2 Determinant of Matrices, 4.3 Inverse of a Matrix, 4.4 System of Linear Equations with 3 variables. 4.1 Matrices. We have several objectives that are we want to identify the different types of matrices, to perform operations on matrices, to define the transpose of a matrix and use the properties. What is matrix? Matrix is a rectangular array of numbers. The order of a matrix with m rows and n columns is m by n. For example, matrix A 1, 2, 3, 4. A has 2 rows and 2 columns, so A is a 2 by 2 matrix. B 6, 8, 3. B has 3 rows and only 1 column, so B is a 3 by 1 matrix. C 2, 5, 9. C has 1 row and 3 columns, so C is a 1 by 3 matrix. Types of matrices. A matrix with only 1 row is called a row matrix. And a matrix with only 1 column is called a column matrix. A matrix with elements that are all zeros is called a null matrix or zero matrix. For example, the following are zero matrices of different sizes. A matrix with the same number of rows and columns is called a square matrix. For example, matrix A is a square matrix of order 2. Matrix B is a square matrix of order 3. A diagonal matrix is a square matrix where all elements are 0 except elements in the principal diagonal. Identity matrix. Identity matrix is a diagonal matrix with all elements in diagonal R1. The identity matrix is denoted by I. Upper triangular matrix. Upper triangular matrix is a square matrix where elements Aij is equal to 0 for I more than j. Lower triangular matrix. A lower triangular matrix is a square matrix where elements Aij equals to 0 for I less than j. Operations on matrices, addition and subtraction. Addition and subtraction of matrices are only defined when they are of the same order. Example 1. A is a 3 by 3 matrix and B is also a 3 by 3 matrix. The sum of A and B is the sum of the corresponding elements in A and B. So A plus B equals to 1 plus 2 equals to 3, 2 plus 3 equals to 5, 3 plus 4 equals to 7, 4 plus 1 equals to 5, 5 plus 0 equals to 5, 6 plus 3 equals to 9, 7 plus 2 equals to 9, 8 plus 4 equals to 12, and 9 plus 1 equals to 10. To subtract matrix B from matrix A, we simply subtract corresponding elements. Multiplication. Two types of multiplication. There are matrix multiplication with a scalar and matrix multiplication with conformable matrix. If A equals to 2, 5, 4, 7, then K times A is equal to K times 2, 5, 4, 7, and this is equal to 2K, 5K, 4K, 7K. Example 2. Let A1453 and B3642. Compute 3A minus 2B. So 3A minus 2B is equal to 3 times the matrix 1, 4, 5, 3 minus 2 times matrix 3, 6, 4, 2. So this is equal to 3, 12, 15, 9 minus 6, 12, 8, and 4. And then we can subtract the corresponding elements. So we will get negative 3, 0, 7, and 5. So this is the answer. Matrix multiplication AB is defined if and only if the number of column of A is equal to the number of row of B. It is important to check orders before starting the multiplication process. If A is a M by N matrix and B is an N by P matrix, then the product of AB is C with order M by P. Example 3. Matrix A has order 2 by 3 and matrix B has order 3 by 3. So to find the multiplication between A and B, the product of AB is the matrix with order 2 by 3 matrix. So AB is equal to 1, 4, 3, 2, 4, 1 times 0, negative 4, 6, 4, 0, 2, negative 6, negative 2, 0. So the answer is negative 2, negative 10, 14, 10, negative 10, 20. Example 4. Given A is a 3 by 3 matrix and B is a 3 by 3 matrix, show that AB is not equal to BA. So if we find the multiplication of AB, so we put the matrix negative 3, 5, 6, negative 1, 2, 2, 1, negative 1, negative 1 times the matrix B, 3, negative 1, 2, 2, 1, 1, 1, negative 3, 0. We will get the answer is 7, negative 10, negative 1, 3, negative 3, 0, 0, 1, 1. And then we can find the product of BA. So we'll write down the matrix B first. 3, negative 1, 2, 2, 1, 1, 1, negative 3, 0 times the matrix A, negative 3, 5, 6, negative 1, 2, 2, 1, negative 1, negative 1. And then we will get negative 6, 11, 14, negative 6, 11, 14, 0, 1, 0. So that we can see that AB is not equal to BA. So we must put the word shown. Transpose of matrix. Objectives. To define the transpose of a matrix and explain the properties of the transpose of a matrix. The transpose of a matrix M by N is a N by M matrix AT obtained by interchanging the rows and columns of A. That is, the ith column of AT is the ith row of matrix A. Example 5. Matrix A 1, 2, 3, 4. To find the A transpose, the first row of 1, 2 becomes the first column of 1, 2, and the second row of 3, 4 becomes the second column of 3, 4. B, we have 3, 6, 0, only one row. So to find the B transpose, the first row becomes the first column. C, 1, 2, 3, 4, 5, 6. Two rows becomes two columns like this. Example 6. Given A 1, 2, 3, 4 and B 1, 2, 3, 4, 5, 6. Find AB transpose. Okay, first we can find the multiplication between A and B. So AB equals to 9, 12, 15, 19, 26, 33. So AB transpose, we change the rows becomes the columns. So 9, 19, 12, 26, 15, 33. Here are the properties of the transpose of a matrix. A. If A plus or minus B in the bracket transpose, it becomes A transpose plus or minus B transpose. B. A transpose and then transpose again, so we will get the original matrix A. C. AB in the bracket transpose, so this is equal to B transpose times A transpose. But remember that AB transpose is not equal to A transpose B transpose. D. K is a scalar that multiply by A transpose, and then this is equal to KA transpose. Example 7. Example 7. Given P 1, 2, 3, 4 and Q 1, 5, 7, 2. Show that P plus Q in bracket transpose is equal to P transpose plus Q transpose. We can prove the expression on the left hand side first. So we need to find P plus Q. So P plus Q is equal to 2, 7, 10, 6. And then we transpose this matrix, becomes the row 2, 7 becomes the column 2, 7. The row 10, 6 becomes the column 10, 6. Then prove the expression on the right side. P transpose plus Q transpose equals to 1752 plus 1324, and this is equal to 2, 10, 7, 6. And this is equal to P plus Q transpose. By comparing the both expression left and right, therefore P plus Q transpose equals plus Q transpose. So example 8, you need to do on your own. You need to show that PQ in bracket transpose is equal to Q transpose P transpose. Thank you.